Okay, so this is our third horizontal launch practice problem. Again, if you have not solved these problems, you want to go back and solve them yourself before you check the answers. If you're getting stuck on setup or something like that, you want to make sure that you email me so we can get you straightened out. But doing these is a very important part of the process. So let's start reading. A horizontal rifle is fired at a bullseye. Muzzle speed of 670 meters per second. The barrel is pointed directly at the center of the bullseye, so this again reinforces that it's horizontal. And it strikes the target 0.025 meters below the center. So we've got a vertical displacement here. What is the horizontal distance? Let me change this to red so it's consistent. What is the horizontal distance between the end of the rifle and the bullseye? So I'll try to draw this as best as I can. We have a bullet. I'm going to use pink for a second because we're lined up directly with the center of that bullseye. Right here. Okay. And maybe I shouldn't have filled that out quite so thoroughly. There we go. Again, your diagrams don't really have to be very detailed. They just want to, make sure they help you with the picture. All right. It has an initial velocity. I'll use blue to do this. An initial velocity which is horizontal and is 670 meters per second. It's going to follow a trajectory that's curved, and it's going to hit the target 0.025 meters below the target. Okay, and they want to know this distance here to here. All right, so let's start filling things in. We have a 670 meters per second for horizontal velocity. We know it's purely horizontal, so we have a 0 meters per second for the y initial velocity. We know that our acceleration in the x direction is 0, so that means these two values are equal. 670 meters per second is the x component of the final velocity. We know that my y displacement is, minus 0.025 meters because we are below where I started for my initial position here, and then we're being accelerated at negative 9.8 meters per second squared down. And we're trying to find this horizontal displacement right here. So I take a look here, and as I'm looking in x, I see the only thing I have is that initial and final velocity. I need time in order to solve anything in this x direction like that. So I'm going to have to find it in the y first. All right, but I can use the no VF formula in the y direction to find that. And my no VF formula looks like the horizontal displacement is equal to the initial velocity in the y direction times time plus 1/2 acceleration in the y direction times time, and my initial velocity is 0, so this goes away. So I'm left with y is equal to 1/2 a sub y t. I'm trying to find t, so before we do anything else, let's get in that good habit of putting t on the left-hand side by itself. So I have 2y over a sub y. So t is equal to 2 times negative 0.025, and we're going to divide that by negative 9.8. And it's really important to carry your signs. You'll notice there's an error if you do not. So I'm going to get a really tiny time, and that was this is squared. This is squared. This is the square root. Time was 0.007 seconds. So my apologies. Let's go back through here. This formula is y equals v naught yt plus 1/2 at squared. And then, so we take the square root. Make sure you understand where I made that mistake. And by the way, dropping that off is a common mistake, so please be really careful about it. All right, now that I have the time, I can go back here in x, and x is equal to v naught xt. So x is equal to 670 times 0.07. So x is equal to 46.9 meters. So my answer is plus 47. And actually they're asking for distance, so it really shouldn't have a sign here. Okay, and you could put away from the target. Okay, so this is my answer, 46.9 meters.